This lesson is going to be an introduction to inequalities. An inequality states that two quantities are not equal or may not be equal. When we talk about inequalities, we use these symbols in replacement of what you might see as in an equation as an equal sign. But these are not equations, they're inequalities. Equations talk about equality. Inequalities talk about inequality, not equal. So we can't use equal signs with our expressions. We have to use symbols that represent something not equal. So this symbol, it stands for is less than. This symbol, open to the left here, and I don't mean to confuse you with that, is greater than. This symbol means is less than or equal to, and this symbol here stands for is greater than or equal to. How I remember them is that less than, this symbol looks like a capital L that's just been squished, okay? A capital L. It has nothing to do with left or right. It just is an L, okay? And same thing with less than or equal to. It's still that L with that little equal under it. And in fact, that kind of looks like an equal sign, less than or equal to. So that's just how I remember it. And if I remember what less than is, the one that's the other way is greater than. So let's talk writing inequalities. Inequalities are going to come about when we're talking about story problems or scenarios or different situations. Here is a situation where it might come about, just in a conversation. There are at least 25 students in my class. What does that mean? What it means is that at least means there are 25 students or more. So greater than 25 or equal to 25. So we can safely say that the number of students in my class is greater than or equal to 25. This brings about a point that must be understood here, is that inequalities are always read from left to right. Because this means is greater than or equal to, something has to be greater than or equal to the number here. So order within inequalities absolutely matters. With equations, we had the symmetric property along with the reflexive property, which said that, things could be equal and be on different sides of the equal sign. This is not true with inequalities. So be very careful here. How about example B? No more than 150 people can occupy the room. So if you were asked to write an inequality for this, you just have to analyze it for a moment. If no more than 150 people can occupy the room, well, how many can? 150 can. Can 151? No. No more than. Can 149? Yes. So if no more than 150, we can have 150 or less, right? So is it true that the number of people must be less than 150, but they can also be 150, so less than or equal to 150. An inequality that contains a variable is called an algebraic inequality. Inequalities can have more than one solution. And in fact, if they have more than one solution, it's often infinite solutions. Together, all of the solutions are called a solution set. So here's first example here. If I say A is greater than 5, then A can be 6, 7, 8, 9, 10, can count forever, right? A is just greater than 5, that's what I know. And all of the infinite rational parts in between. So if A is greater than 5, then 5 and 100th is greater than 5. So it's included as well. 5 and 100th, 5 and 200th, 5 and 1,000th, 5 and 1,000,000th, okay? Anything greater than 5 is included in the solution set. So that's why I'm saying solution sets can be infinite. So we can represent the solution set on a number line, and I love this. So I'm going to represent A is greater than 5. When I do that, here's my number line, I locate 5, and it's greater than 5. So I'll put an open circle, and all of the numbers that A can possibly be are going to be represented off this circle with an arrow. Remember, we thought about what A could be. It can be 6, 7, 8, etc. So I'm going to draw my arrow toward those numbers. And again, it's an arrowhead because it's all of those numbers that are to the right. Okay, infinitely. So that's what that arrow represents. And it's an open circle because 5 is not included here. So we don't want to fill it in because that would mislead us into thinking that 5 was included. And A is greater than 5. It's not greater than or equal to 5. Here's another one. If x is less than or equal to 3, then the graph shows all possible values for x. So x is less than or equal to 3. I locate 3, and because this time it's less than or equal to, I can fill in that circle because x can be equal to 3. And it's less than or equal to 3, so it's all the values less than 3 as well. So 2, 1, 0, -1, -2, but it's not just dots that way because remember all those fractional pieces are included. So it's everything to the left on the number line of 3 and also including 3. Here's your note to make sure you understand this concept of the filled in circle or the open circle. Filled in circles mean that the number is included in the solution set. This is going to happen when in your inequality you have less than or equal to and greater than or equal to. Open circles mean that the number is not included in the solution set. This is going to happen when you have a greater than symbol or a less than symbol. Let's practice, okay? If x is greater than -2, I first have to locate -2 and I put the circle there. Once the circle is there, I decide, is it opened or closed? Does my solution include -2? X is greater than -2. So -2 cannot be a solution for x. But it's all of the values greater than -2, so starting at -2 and all of the numbers greater than it are going to be plotted here. And it looks just like that. That's it. How about y is less than or equal to -1? Well, let's locate -1. Less than or equal to. Is -1 included for y? Can -1 be y? Absolutely. Less than or equal to. So I fill in my circle because -1 is part of the solution set. And it's all numbers less than or equal to -1. So it's all of these numbers to the left. Okay? Less than -1, less than -1 in value. There you go. And then here are some additional examples that we're just going to work through together. As this is just an introduction to inequalities, we pretty much leave it at that. Write an inequality for each situation. There are at least 15 people in the waiting room. So if there are at least 15 people, then there are 15 or what? More. At least 15. That means there can't be less than. So there are 15 or more, which if there are 15 or more, I want to say there are greater than or equal to 15 people. And you can put people, you could actually represent the number of people with a variable. If you'd like to, the number of people is greater than or equal to 15. And there you go. How about this one? The tram attendant will allow no more than 60 people to ride at one time. So the maximum amount you can have is 60. Can you have fewer than 60 or more than 60? Are you allowed to have more than 60? No more than. Okay, it's important. I can't have more than 60, but I can have 60. So it's possible that I'm equal to 60, and I can also be less than 60. So if we think about those together, that's less than or equal to 60. So the number of people on the tram must be less than or equal to 60. And that's writing an inequality. Okay? How about this? Let's graph each inequality. And I have the number lines empty here because you need to be comfortable with filling in your number line based on what you need. You're not always going to be given one that's spaced out perfectly. So if n is less than 3, I know I need to work with 3. And to the right of 3, I have 4 and 5. To the left, I have 2 and 1. And that's really all you need. You don't need to go crazy. It doesn't have to be massive. It can be very short, and you get the point across. n is less than 3. So I graph a point at 3. Does n include 3? No, it's not less than or equal to 3. It's less than 3. So it's going to start at 3 and be all of the numbers to the left of 3 that are less in value. And that's a terrible circle. Not filled in. Less than 3. Forgive me here. Okay. A is greater than or equal to -4. This is why I wanted you to fill in your own number line. Because you know you need to start at -4. But what's to the right of -4? Greater in value. It's not -5. Be very careful. Okay? As we move more toward the positive, this is -3. And this is -2. To the left is -5 and -6. So A is greater than or equal to -4. Because it's greater than or equal to, my circle is filled in. And it's all of the numbers greater than or equal to -4. So I take my arrow to the right. Lastly, X is greater than -3/4. Oh, fractions. It's okay. -3/4. So it's okay. -3/4, just put it on your number line. You can be comfortable working with fractions. If I'm a little bit more negative than -3/4, can't I just say -4/4? That is equivalent to -1, but you can represent it in fourths. I love that you would actually make that connection. To the right is going to be more positive. That's going to be -2/4 or -1/2. This is -1/4. You can have -0, you can have 0/4, so you could write 0, right? 0/4 is 0. And you can even go as far as saying -5/4. This is completely acceptable. Or you could write their equivalent fractions that are simplified. Either way, I love this. So X is greater than -3/4. -3/4 is not included in the solution set, but it is where our solution set begins. So we put an open circle at -3/4, and it's greater than -3/4, so it's everything to the right greater in value than -3/4.